All right, good morning, guys. We're going to be talking about clutches and then manual transmissions, but first clutches today. So the purpose of a clutch is to separate the engine power from the transmission so you can shift gears. So we've got power coming out of the back of the crankshaft. We've got to disconnect that from the transmission in order to shift gears. You've got power going through the transmission, you're not going to be able to shift gears. So to separate engine power and transmission in order to shift gears, as it says, number two system types. We have mechanical or linkage operated or cable operated clutch systems, or we have hydraulic. And everything today is hydraulic, where we have a clutch master cylinder. When you push the pedal, you're pushing fluid down to a slave, either on the outside of the bell housing, right out here to operate this fork, or you have a hydraulic throw-out bearing that pushes on the pressure plate. So here's a clutch master cylinder. It's got hydraulic fluid, which is brake fluid, usually .3 brake fluid. You push the pedal here, fluid comes out and goes down to a clutch slave that's either against the fork here to actuate this throw-out bearing on the pressure plate, or you have a hydraulic bearing like this, and this is what you normally have today, where this is bolted to the transmission. There's the throw-out bearing, fluid comes in, this is for bleeding, and that actuates the pressure plate there. Let's keep going. So our components of a clutch are going to be the pressure plate, the clutch disc, the throw-out bearing, a pilot bearing. There's a pilot bearing there. Most cars, it's in the back of the crankshaft, unless it's a front-wheel driver, and then we don't use that. We don't have a pilot bearing on a front-wheel driver typically. And then a flywheel. So there's our flywheel. And then the clutch fork. There's our flywheel, and there's our clutch fork. And the flywheel serves two purposes. It's an inertial wheel. It's a very, very heavy-duty wheel to keep torque and energy in motion continuing to spin, so it preserves engine momentum. And it's also a flat spot for the pressure. It's a mounting spot for the pressure plate, bolts onto it. And it has a machine surface for the disc to rub against it and connect the engine and the transmission. Let's keep going here. So let's talk about our clutch components specifically. First, the pressure plate. Pressure plate is a disc clamp. It clamps the disc to the flywheel. Three types: a diaphragm clutch, most commonly used in all cars today; a Borg and Beck style, which is a 3-finger, or what they call a long style, which is also 3 fingers. This was old school Fords and stuff like that. Think 50s and 60s. A Borg and Beck is typically a high performance clutch. Think serious race cars, real heavy clutch, hard on the foot pressure. Everything today is a diaphragm style. We have a lot less pedal pressure that we need to disengage the engine and transmission. Then we've got the friction disc. So here's the clutch disc. And the clutch disc is splined. You can see the internal splines here to the input shaft going into the transmission. So here's a disc, and you can see those splines right up there, right in here where my finger's coming through, that spline this to the input shaft of the transmission. So this drives the transmission. The way it drives the transmission, it's splined to the input shaft of the transmission, but the pressure plate's going to clamp on these sectioned friction material pads, grab that plate, and then spin it. So it says spline to the transmission input shaft in order to drive it here. Double-sided friction plate between flywheel and pressure plate. So you have friction surface here and on the other side here, on both sides of that disc. It's got torsional hub springs. These guys are torsional hub springs to cushion engine force on the disc. So when you grab this plate, this hub will move like this, about a ½ inch max, 3/8 of an inch, and these springs are absorbing that energy. So when you let out the clutch, you don't just rip the metal piece right off the disc. There's a little bit of cushioning. And then there's what's called Marcel springs between the disc lining surfaces that cushion it. So there's actual springs. You can see this sort of bent steel shim between the two friction discs. It's just a piece of steel that's sort of bent, and when the disc gets compressed, it offers a little bit of resistance just to cushion the impact of the pressure plate coming down on the disc. Let's keep going here. So we've got a release bearing, third component, or throw-out bearing, and you can see it there in the picture. And here is a brand new hydraulic throw-out bearing here, and here's an old school, this one's the old school style throw-out bearing there, where you can see the two contact points where the plate grabbed it right there. And this one is a hydraulic one that gets actuated hydraulically to release the pressure plate. So it releases the plate from the disc. You can have a conventional mechanical one like this, or you can have a hydraulic like I was just showing you. Next is our pilot bearing. This is going to support the end of the input shaft bearing. I said input shaft bearing, but what I really meant is just the end of the input shaft. So this is the input shaft going into a transmission, and the pilot bearing, like this one here, is going to support this right here. Now this one's actually too small for it's not for the right car, but this is pressed into the back of the crankshaft. The input shaft goes in there, and that's what supports this input shaft on the outer end is the pilot bearing, and centers it around the crankshaft because that's where the clutch is. What you have in the picture here, which just says supports end of input shaft in the end of the crankshaft. All right, so next, what you've got there is two styles of pilot bearings. One's a roller type, right here, which everything is today. And the other one's a bushing type, which I think it might say that, yeah. So this is a bronze bushing. Both of these would push into the back of the crankshaft, one or the other. This would be like a 60s Chevrolet, and that would support the outer end of the input shaft bearing. And this one's obviously got rollers and it's got grease, and so it's going to last a lot longer. Okay, next is flywheel. So the flywheel preserves momentum by being an inertial wheel, heavy inertial wheel. It's a clutch mounting surface here, so the clutch disc can ride on there. It also mounts the ring gear for the starter motor. And just so you know, these ring gears are not welded on, they're pressed on, so we can beat them off with a hammer and a chisel, and then we can heat a new one up with a torch and drop it on and change it if the teeth get beat up. And I've done that many times. And just a couple other things about the flywheel. On some engines, they are externally balanced, so there'll be a heavy weight on this flywheel. Then some engines are internally balanced, but in either case, the flywheel is used to balance some of the mass of the engine. Next is the clutch release fork. Here's a clutch release fork. Pushes the throw-out bearing by way of a rod, cable, or clutch hydraulic slave cylinder. That clutch release fork, I just want to remind you, is here's a clutch release fork and with the throw-out bearing on it. Well, that's completely eliminated, I'll show you, by this hydraulic throw-out bearing. So this has a lot more, excuse me for my COVID sneeze. This one has a lot more mechanical friction, if you will, and wearing points, and this is a lot less. This is a lot easier on your foot, etc. Next is the over-center spring on the pedal. And so on your clutch pedal, you have an over-center spring. What that is so that as you push the clutch down the first part of the way, about the first third, it's hard. And once you get past the center position, it gets easy. So that makes the pedal be all the way up or all the way in. We don't want the pedal anywhere between there as much as possible because that wears the disc out. So we either want the foot all the way off the pedal or the pedal all the way to the floor, in which case, in both those scenarios, we are not wearing the disc and the pressure plate. Although somebody could argue that we are wearing the pressure plate springs, and that's of course true. This keeps the clutch fully engaged or it keeps it fully released. It's called an over-center spring. So if you put your clutch pedal, you'll notice it's a little hard at first and then it gets a little easier towards the floor. Okay? So the function of a clutch, engagement. Engagement means our foot is off the pedal. And this is sort of counterintuitive, meaning your foot's off the pedal and the pressure plate is clamping the disc to the flywheel and the engine is driving the transmission. That's engagement. Engagement means your foot's off the pedal, the plate is clamping the disc to the flywheel, and we're driving the transmission. Disengagement means we push the pedal in, we depress the pedal, the pressure plate releases the disc, and the engine and transmission will spin independently of one another so I can shift gears. So again, engagement is foot off the clutch pedal, disengagement is foot on the clutch pedal, engagement, the pressure plate is clamping the disc, disengagement, the pressure plate is releasing the disc. So a little bit of problem diagnosis with clutches. Let me see if I can get that thing to focus there for one moment. There it goes, so it should focus now. Nope, it's not doing it. Sometimes this has trouble. Let's see if I get in front of it. There it goes, okay. So next is problem diagnosis. So the most common problem scenario with a clutch is clutch slippage, where we have a worn disc. So the disc friction surface of this plate gets thin, okay? And so the pressure plate can't grab the disc as easily, or weak pressure plate springs. Clutch chatter is, and by the way, in this scenario, of course, the clutch just needs to be replaced. Clutch chatter, which is I let out the clutch and the whole transmission and drivetrain just vibrates, and it can be pretty violent, actually. It's kind of an older car kind of thing. That can be fluid contamination on the disc. It can be warpage of the flywheel or pressure plate. It can be misalignment. I once read an article in Hot Rod Magazine, and they had 35 things listed that could cause clutch chatter. So if you ever take an ASC test for transmission and clutches, and they say, what causes, can this cause clutch chatter? You say, yes, everything causes clutch chatter. Okay, hard shifting. Hard shifting can be improper fluid level in a manual transmission, MANTR, manual transmission, a defective pilot bearing, worn pressure plate fingers, misadjustment of the clutch, air in the hydraulic system. Any of these things can cause hard shifting. All that means is that the disc is not being completely released by the pressure plate. So anything that actuates the disc or the disc itself can cause this to not get completely and independent from the engine. And then it's hard to shift, because when there's power going through the transmission, the gear shifter does not want to force things together. High pedal engagement. So if you're lifting up on the clutch pedal, lifting up, let me do it this way. If you're going up, 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 and then finally it engages the disc and drives the car, you either have a worn out disc, a worn pressure plate spring, so they're not giving you enough clamping force, or the clutch is misadjusted. Now, there is no adjustment on clutches anymore, hydraulic clutches, but old school clutches, we did have adjustment. Now, sorry, I need to be careful here. There is some adjustment on some modern cars under the dash, where the pedal goes in with a rod, goes into the clutch sleeve cylinder. So you can see, for example, or the clutch master cylinder. This lock nut here, I can turn this yoke, and I can, in relation to that rod, and I can change my clutch adjustment. So I apologize, there is clutch adjustment up at the pedal, but old school stuff, there was clutch adjustment down at the throw up, or sorry, at the clutch fork. Okay, let's keep going here. So noises, a throw out bearing noise. So throw out bearings will make noise under two scenarios. When they're really bad is when you push the pedal in and they start squealing like crazy. Let me show you one that was grenaded. This is what's left of a Toyota Tacoma throw-out bearing. Look at this thing, it's just all in pieces. And we pulled this out, and it just literally just all fell out in pieces, and all the rollers just came flying out when we pulled the transmission back. And that is just a grenaded throw-out bearing. Okay. Some throw-out bearings will sing a little bit when your foot's off the pedal, and they'll just kind of, and then you just barely touch the pedal and it goes quiet. That's a bad throw-out bearing, or a dry throw-out bearing. Pilot bearing. When a pilot bearing is worn, you typically won't hear a pilot bearing, but it does make a little bit of noise. Just I have not heard of much. Input shaft bearing. Well, this is the one we all hear. When you have a transmission that's making noise, idling in park, and the car's not moving, and you press the pedal down, you engage the pedal, and it goes dead quiet, that's a bad input shaft bearing. Let me show you what that is. So this input shaft and this bearing here This goes down here. This is not actually the right one for this car. If it were, this bearing would move all the way over to there. So this big bearing supports this guy. And when you push the clutch pedal in, this input shaft stops spinning altogether, as long as the car's not rolling forward, but even in some cases when it is. So that means that bearing stops. So when you put the clutch in, this thing stops, it goes quiet, you know you have a bad input shaft bearing. Because of all the force of the engine going through this bearing, they're notorious for wearing out and having issues. It's not uncommon at all to have a bad input shaft bearing after time. Gear noise. We can have some gear noise, just some whining together. There was a Muncie M22 called the Rock Crusher. It had, there was a racing version of it that had straight cut gears. Instead of being helical on an angle like this, they were straight cut. Really great for racing, transmits incredible horsepower, but they're sure noisy. And then we have the classic synchronizer grinding, and I would like to show you what that is, but on this input shaft, here's the synchro teeth. And when I shift, this is actually a cone, you can see it's tapered. When I shift this, a synchronizer is going to go over here. And if these teeth are not aligned properly or they're worn out, then we hear grinding. And so the grinding noise that we hear when we shift is from the synchro swearing. When we look at manual transmissions, we'll go a little further with that synchronizer noise. Okay? So service procedures for clutches. We're going to replace the pressure plate, the disc, the throwout bearing, the pilot bearing. Anytime we do a clutch, we're replacing all those parts. And additionally, we're going to surface the flywheel or replace it. We're going to eliminate its warpage, cracks, heat checks, and burn. Heat checks are small little cracks in the face of the pressure plate. Believe it or not, those are not dangerous of catastrophic failure. When we machine it, usually it'll machine all those heat checks out. But if you have a flywheel that's been machined, you can still see what looks like little cracks. It's okay. Okay. So we're going to machine the flywheel so that we have a nice parallel surface for the disc, a flat surface. Clutch alignment. The bell housing and the disc with the input shaft all has to be aligned properly. And so when we're putting new clutch in, we use a little clutch alignment tool to get the disc centered around the center of the crankshaft. And then adjustment. We're going to adjust the pedal free play. Free play is when your foot's touching the pedal and you push down to where it gets pressure. You usually want about 3/4 of an inch of clutch free play. That's from full rest position to where it just starts to push on the throwout bearing and the pressure plate. We usually want about 3/4 of an inch of free play. We also need to bleed the slave cylinder or throwout bearing, hydraulic throwout bearing from time to time. And this is a bleeder valve to keep air out of there and keep the fuel clean. That's a normal service procedure at times, etc. Okay, that's it for now. We'll talk about manual transmissions next.